Hi, this is Kristina presenting for Group 8, Chapter 18, Create Review and Coordination Processes to Increase Quality. Introduction. One of the things that's important to do is to enable dev and operations to reduce risk before changes are made. And that's our goal in this chapter, is to get that done ahead of time. One of the essential parts of this is doing a pull request, or this has been popularized by GitHub. They pioneered this process, and it shows how inspection can increase quality and make deployment safe and be integrated into the flow of everyone's daily work. They're the mechanism that lets engineers tell others about changes they have pushed to a repository on GitHub. They are also the mechanism used to deploy code into production through a collective set of practices called GitHub Flow. There are 5 steps, and I'm going to list all these steps one by one, partly to help my own memory and to help anyone else who watches this. So GitHub is used at my work, and many of us will probably use it, so I think it's helpful to break down the 5 steps to getting a pull request merged into master. Number 1, create a branch from master. The engineer creates a branch or fork, and this effectively is the same thing as like a save as file. And you save the master as a new branch, and then you just give it a new name, and that's how that works. Second, you commit changes to the branch. So the engineer makes all their commits and changes into the branch, which is actually, it can be saved on their local computer or online. And then third is we open a pull request. So you do this for 2 different reasons. 1, when the engineer thinks that the code's ready for merging, or 2, when they are ready for feedback and help from the other engineers. Fourth, you actually merge it. So after reviews and approvals, the engineer can merge it into master. And then 5th, you deploy. So once the code changes are merged to master, the engineer can deploy them into production. This process allows GitHub users to quickly and reliably deliver features to market with high quality and high security. And our goal in this chapter is to shift to integrated peer review that's performed continually as part of our daily work, and the pull request really helps in that. Now, there are dangers in of a change approval process. We're going to talk about that. So first of all, there was this dramatic thing that happened with Knight Capital Group. On August 1st, 2012, a technician from Knight forgot to copy the new retail liquidity program code to one of their automated routing systems for equity orders. And this code used a flag that would move stock prices higher and lower. And without that code, the flag, known as PowerPeg, went into action for real, causing stock prices of 150 different companies and 397 million shares to rise over the course of 45 minutes. The error cost Knight Capital $460 million and is one of the most prominent software deployment errors in history. When incidents like this occur, there are typically 2 counterfactual narratives for why it occurred. A counterfactual statement relates to what has not happened. An example, the sentence, if kangaroos had no tails, they would fall over. It's a counterfactual statement. It's contrary to fact. So this is, telling it like it wasn't. So there's 2 narratives here that we commonly see that are typical. And one is, the first narrative is that the incident was due to a failure of the change control process itself. This seems valid because it seems like if we had better change practices, this wouldn't have happened, but that's contrary to fact. However, the response is usually to add more questions to be answered and require more authorizations and approval before a change is made. We'll find out later that that's counterproductive. The second narrative is that the incident was due to a testing failure. This also seems valid. If we had done better testing, we could have identified the risk earlier and prevented this, but this is also contrary to fact. The surprising reality is that if the environment is low trust and has command and control processes, then the change control and testing measures are likely to increase the likelihood that those problems will happen again with even worse outcomes. So it's not likely it will decrease, but rather increase. Now, there are potential dangers of overly controlling changes, and the people closest to the problem know the most about it. So traditional change controls can lead to unintended outcomes. The solution is to build a high trust culture. It's been said that building a high trust culture is likely the largest management challenge of our decade. And high-performing organizations rely more on peer reviews and less on external approval of changes. The more organizations rely on change approvals, the worse their IT performance is in terms of stability and throughput. So it is important, though, to also enable the coordination and scheduling of changes. And we need secure lines of communication between teams. When teams share dependencies, they need to communicate with one another so they don't interfere with each other. Even in loosely coupled architecture, many teams are doing hundreds of independent deployments a day, and we reduce that risk by having a chat room of sorts to announce changes and avoid issues. In my company, we use Slack. In more complex organizations, or if they have tightly coupled architectures, they deliberately schedule change ahead of time. This is to schedule and sequence it in order to minimize incidents. But even in large organizations, this can take weeks to even months, and the bigger the company, the longer it takes to adapt to change. So it's also, we need to enable peer reviews of changes. Before we make change, we have our code peer reviewed. Instead of requiring approval, we have engineers get peer review on their changes. And the reviews benefit our changes, peer learning, and skill improvement. So their guidelines, everyone must have some code to, must have someone review their changes to the code, the environment, etc. before committing to the trunk. Everyone should monitor the commit stream of their fellow team members so that potential conflict can be identified and reviewed. And we need to define what changes qualify as high risk and may require review from a designated subject matter expert. If the commit is too big, we split it into smaller sizes. The larger the batch, the more review is required. And one way to do this with code reviews is with pair programming. So programmers work in pairs. It's like there's a couple different styles. Over the shoulder, one developer looks over the other shoulder as the latter works through the code and walks through the code. There's also an email pass around, a source code management system, emails code to reviewers automatically after the code is checked in. And then there's a tool-assisted code review where authors and reviewers use specialized tools designed for peer review in like GitHub, for example. Dangers of doing more testing and change freezes. So we need to fully integrate testing into our daily work to be smooth and continually flow into production. By doing this, we build in quality, which allows us to test, deploy, and release in smaller batches. Manually testing, as we know, takes longer and is a slower process. It's more tedious and often requires you to perform additional testing. This increases our batch sizes. We know in theory, the larger your batch size, our change success rates go down and our incident counts go up. So it's good to enable pair programming to improve all of our changes. And this is when two engineers work together at the same workstation. And in one common pattern, one engineer fills the role of driver and the other person who's the person who actually writes the code, and the other engineer acts as the navigator, observer, pointer, and the person who reviews the work as it's being performed. So there's benefits to this. Two heads are better than one. It's more efficient. You wind up with fewer coding mistakes, and it's an effective way to share knowledge. Let's evaluate the effectiveness of pull request processes. So pull requests let you tell others about changes you've pushed to a Git repository, and once a pull request is sent, interested parties can review the set of changes, discuss potential modifications, and even push follow-up comments if necessary. So a bad pull request is one that doesn't have enough context for the reader, having little to no documentation of what the change is intended to do. For example, a pull request that merely has the following text: fixing issue, XYZ and XYZ. That's not a great pull. That's a bad pull request. But a good pull request that has sufficient detail on why the change is being made, how the change is being made, as well as any identified risks and resulting countermeasures. And we need to fearlessly cut bureaucratic processes. So bureaucratic processes are long-standing processes for approval that require months to navigate, and they can significantly increase lead times and prevent from delivering value quickly to customers. When this happens, we must re-engineer our processes so that we can achieve our goals more quickly and safely. And in conclusion, we discussed how to integrate practices into our daily work that increase the quality of our changes and reduce the risk of poor deployment outcomes, reducing our reliance on approval processes. To do this kind of work requires a high trust culture. And one of my favorite quotes from this chapter said that if you give an engineer 10 lines of code to review, he will find 10 problems. If you give him 1,000 lines of code, he will say it looks good. And I think that's a key to what we are doing here and why it's important to have small incremental changes that are reviewed frequently. Thanks so much for watching.